Good morning, dear children. Now today we will come to the next principle of flotation. Now you know the body, when the body is immersed in a liquid, okay, the body they sink or they float. Or when the body floats, okay, what makes the body to float? There is a principle, and the principle it states that the principle of which we call it as a principle of flotation. Now this principle of flotation it states that when a body floats in a liquid, the weight of the floating body is equal to the weight of the liquid displaced by it. The weight of the floating body is equal to the weight of the liquid displaced by it. Now what we try to explain is that, now let us consider a container which is filled with water. Okay. Now the body will float here. The body floats. The body doesn't sink. The body, it floats in the liquid. And what makes the body to float is that the weight of this body, which is immersed in a liquid, should be equal to the weight of the liquid displaced by it. That means how much water, when it is immersed in a, when this body is immersed in a water, how much water the body will displace, and that water which has been displaced by the body should be equal to the weight of the body, which is stated by the principle of flotation. Okay. Now the two forces, when the body floats or when the body is immersed in a liquid or in a water, two forces acts on it, acts on the body. Number one is the weight of the body W1. One force is the weight of the body W1, which acts vertically downwards. One force is here, that is the weight of the body itself. That force is the weight of the body itself, which we consider as W1. So number one is the weight of the body W1, which acts vertically downwards, and other one is here the buoyant force or the upthrust, which acts vertically upward. That means the two forces act on a body when the body is immersed in a fluid or in a liquid or in water. One is the downward force, other one is the upward force. So that downward force is considered as the weight of the body, and the upward force is considered as the buoyant force or the upthrust. Okay, now taking that condition here, let us take the three conditions here. Now the first condition is here, when W1 is greater than W2. That means when the weight of the body is greater than the upward force or the buoyant force, then the body will sink. That means the weight of the body is more. When the weight of the body is more, the upward force given by the liquid to the body will become less. So when it will become less, the downward force will become less, will become more. Upward force is less. So therefore the body will sink. So therefore the condition is here, when W1 is greater than W2, then the body will sink. Second condition is here, if the weight of the body is less than buoyant force. If the weight of the body is less than buoyant force, that means the buoyant force is more, upward force is more. So in that case what will happen? The body will float partially on the surface of the liquid. Body will float partially. Partially means half part of the body will remain under the water, under the liquid, and the half portion of the body will be above the surface of the water. So that means they will float partially on the surface of the water. So this condition will, in this condition, the body will float partially when the weight of the body W1 is less than the buoyant or the upward force. Third one is here, when the weight of the body is equals to the buoyant force. So that means both are equal now. The downward force and the upward force both are equal. Now when they become equal, the body will just float below the surface of the liquid. It doesn't sink, but the entire body will remain, the entire portion of the body will remain under the water and then will float. Okay, so these are the three conditions in which when the body is immersed in a liquid, okay, how the body will float. Whether the body floats partially, or the body will sink, or the entire body will remain just under the fluid, under the surface, and it may float. So these are the conditions. Okay. Now the next point, let us come to the next point, that is the apparent weight of the floating body. So already I discussed that apparent weight means not real, and this apparent weight will take place once the body is immersed in a fluid or in a liquid. First you find the weight of the body in air, it is more, and same body when you immerse in a liquid, that body weighs less in liquid. Okay, now why they weigh less in the liquid is that because of the liquid, because of the buoyant force which has been exerted by the liquid towards the immersed part of the body. So in that case, when a body is immersed in a liquid, the apparent weight equals to the apparent, how we calculate apparent weight? Apparent weight equals to upthrust minus actual weight minus upthrust. Actual weight means the weight in air minus upthrust. Okay, but in case of flotation, but when the body floats, in case of flotation, what will happen is that the apparent weight will become zero. When a body is immersed in a liquid, okay, the two again here also the two cases are there. When a body is immersed in liquid, the body weighs less. That means the apparent weight will be less. So apparent weight you will calculate it actual weight minus upthrust. When you calculate it, an apparent weight will always become less. But the other condition is there, the apparent weight can be zero. Okay, so the apparent weight, when the apparent weight can be zero is that when a body floats, when you put a body in a liquid, apparent weight will be accelerated in the body. It creates apparent weight there. But when a body is immersed in liquid and when that body will float, then what will happen? The apparent weight now will become zero. Once the body floats, the apparent weight will become zero. Okay, that means when a body floats here, the upthrust, that is the upward force or the buoyant force will be equal to the weight of the body. So when the buoyant force will be equal to the weight of the body, therefore the apparent weight will become zero. So in a floating body, when a body floats, the apparent weight will become zero. Okay, and the next point is there. Let us come to the condition of flotation. Two conditions are there. In order to make the body to float, two conditions you have to follow. The first condition is there, the weight of the liquid, the weight of the liquid displaced by the body should be equal to the weight of the body. Okay, that means the first condition is there, the weight of the liquid displaced by the body should be equal to the weight of the liquid. So that means the downward force and the upward force should become equal. Next point is here, the center of gravity. This is a new point for you, center of gravity. Center of gravity means it is a point on a body where the weight of the body acts vertically downwards. Okay, center of gravity means it is a point on a body where the weight of the body acts vertically downwards, which we call it as a center of gravity. And other one is known as the center of buoyancy. It is a point on a body in which the weight of the liquid or the buoyant force acts vertically upwards. Okay, so the second condition should be there is that the center of gravity and the center of buoyancy should lie on the same line. Both the center of gravity and the center of buoyancy should be on the same line. That means this is the point, center of gravity and the center of buoyancy should be on the same line. Okay, so if they doesn't lie in the same line, they are not equal or they are not same, then in that case the body doesn't float. So there are the two conditions in which the body floats. Is it clear? Now the next point is here. I'll give you one application of the flotation. A very common phenomenon is there. Application in the uses of flotation. Now let us consider an iron and a ship made up of iron. Okay, an iron nail. Just take let us consider iron nail. When you drop iron nail in a water, the iron nail they sink, they drown. But a huge ship which is made up of iron, okay, it floats. It's quite amazing. Okay, a small nail which is made of iron, it sinks, but whereas a huge ship which is made up of iron, it floats. Now, how it happens is that now iron, as you know, now why the iron is drowned? is getting drowned in the water, or why this iron gets sink in the water, is that now the density of iron is more than the density of sea water. Okay, the density of iron, that means the weight of the, we can consider the weight of the body is more than the upthrust, or the density of the iron is more than the density of water. Okay, and therefore, when the density will be more, the weight of the body, that means the weight of the iron, will be more than the upthrust, upward force. So therefore, what will happen? The iron will sink. But a ship made of iron, they will float. And these ships are made in such a way so that the inner part of that ship is hollow. The inner part of the ship is hollow. Okay, and when the ship, and let us consider this nail, okay, and this nail and a ship. Okay, let us consider a ship, and this nail will displace less amount of water. Look at it. Whatever the amount of water which the nail is displacing, it is less, and the ship is displacing more amount of water rather than the nail. Okay, and inside the ship, and though the ship will float, okay, and inside the ship are constructed, these are made in such a way so that the inner part, inside it is hollow. Okay, and the weight of the ship, that means the water which is displaced by the ship, will become equal to the weight of the ship. Whatever the water which has been displaced by the ship, that means this amount of water, from here to here, this amount of water will be displaced by the ship, and whatever the amount of water which will be displaced by the ship will be equal to the weight of the liquid. So because of that, the ship which is made up of iron, it floats. Okay, so the next other one is also there. That is, it is very easy to swim in a sea water than in the fresh water. Because in a sea water, the density is more due to the presence of salt and minerals. Okay, so when the density is more, the upthrust will be more. So that is why when a body is immersed in the sea water, the upthrust become more, and the water will push the body upward, and therefore the body will flow. So it becomes easy to swim in a sea water rather than in a fresh water. So all these are the applications of flotation. Thank you.